In this video, we are going to classify signals as energy and power. So let us begin with first the power signals. So a simple definition, a signal is said to be power signal if it has finite amount of power. So simple definition goes in this way. The signal has finite amount of power. And it is denoted as so P is nothing but the power of signal and its value is finite. Generally, periodic signals are power signals. Now we can represent the equation of power signal for CT signals. Power P is given as limit t tends to infinity 1 upon t integration from minus t by 2 to plus t by 2 mod of x of t square dt. Here this mod is generally used when we have a complex signal. For a real valued signal, this mod is not necessary. So in general terms, we specify mod here so that we can accomplish the complex signals also. Similarly, the equation for power with dt signal is given as P is equal to limit n tends to infinity 1 upon 2n plus 1. Now this integration changes to summation n equal to minus n to plus n mod of x of n square. Again in this equation also we have this mod for a complex valued signal. For real valued, we can remove this mod and simply take x square of n. Remember here in these two equations, for CT signal we have limit t tends to infinity 1 by t integration from minus t by 2 to plus t by 2, and for dt signal we have p equal to limit n tends to infinity, and here the denominator factor is 1 upon 2n plus 1, and the limits of summation are from minus n to plus n. Now we will see the definition for energy signals. A signal is said to be energy signal if it has finite amount of energy, and it is denoted as 0 E less than infinity. So E is with finite value and it is represented in this way. Now generally the time bounded, or we also call it as time limited signals are energy signals. Now let us see the representation of this energy signal in the equation form. Let's start with the CT representation. For CT signal, the equation for energy is given as E equal to integration from minus infinity to plus infinity mod of x of t square dt. Here again this mod is for complex valued signal, and if it is real valued we can remove this mod. And for discrete time representation we have energy equal to summation n equal to minus infinity to plus infinity mod of x of n square. Remember here, in case of energy, it is straight away simple integration from minus infinity to plus infinity, and generally this energy signals are time bounded, means it starts at one point and ends at another point. Therefore, we integrate these signals for that particular limits. Whereas in case of power signals are periodic signals. So most of the periodic signals will result into power. So now let's differentiate power and energy signals. So let's have the differentiation for, let's say, energy versus power. Let's say first we will have column for energy and then column for power. So first of all, the definition: energy signals have finite energy, so we represent it as E greater than 0 and less than infinity. Same way, power signals with finite power, so it is denoted as P greater than 0, less than infinity. Second, energy signals are time bounded. Power signals are not time bounded. Then third, energy signals are non-periodic, whereas power signals are periodic. Next, very important differentiation here: power of energy signal is 0. That is, if we try to find out power of energy signal, it will come 0. Similarly, energy of power signal is infinite. So if we try to find out energy for power signal, we will get answer as infinity. This is very important differentiation. So while solving numericals, if we try to find out power of an energy signal, that power will be equal to 0. That means we need to find out its energy. Similarly, if we try to find out energy for a signal, and if that particular signal is a power signal, we will get the value of energy as infinite.